So, folks, I guess I will start off by saying this is a great opportunity, which I think several of us at Ames have been looking forward to for some time, to hear about the workings of Pandora. We have one on the roof, and we'd like to make better use of it. At this point, though, we have a really good description of how to use Pandoras for getting vertical profiles of NO2, and our presenters will be basically. Alex Kotsakis will give us the whole setup of how things are in Houston, and Elena we hope chip in and take any questions about just what's going on in more detail. Several of us actually do retrievals, and so we may have some interest in knowing how does it go right, how does it go wrong. Arthur Mitzi will be interested in retrievals, I think. And we have Charles HCHO visiting us too, which is great. Okay, so what can we say? Alex, let's see. It mentions that he got into this whole thing as a meteorologist and very much an ozone meteorologist at Valparaiso University. He was as an undergraduate, and then off to University of Houston, where he worked first with Barry Leffer, and then later on with, what's his name?
Choi.
Choi. I write him loose and I still forget the name. Anyway, so he's really taken a strong interest, and here we have a new way of taking a look at the boundary layer structure of the atmosphere and all the complications that you get into, especially for a place like Houston. I should mention that I have a couple of geographical connections with a couple of these people here. I went to Rice University undergraduate, and I lived near the area, smelled all the stuff that was coming out of the refineries all the time, and so I'm very interested in what's going on in Houston. And on the other hand, I have great interest in the Pacific Northwest. And Elena actually did a lot of her great work and really got the U.S. started with Max Doas in large measure at University of Idaho and about 10 miles away at Washington State University. In Washington State University, I spent a great year learning much more about ozone. And Elena originally got her degree in Moldova, and then came to University of Idaho, and then across the border to Washington State, where in an engineering application. So you'll see that there's quite a bit of technical and engineering, computer science in what she is doing. Hope I've got that right. Now let's see. Alex is now at Goddard, where he's working with ERT as a contractor at Goddard, and had an opportunity to work with Bob Swap and Tom Hanisco, and is now setting off with his own meteorological explorations. And Elena has been around Goddard for a long time, but she is now at Virginia Tech University, so it's Professor Elena Spinei Lind. You'll find a few papers out by Elena Spinei. And so with that, I think we should get going and ask Alex to tell us about tracer IQ, and then to have questions come up. We're going to have this, ask brief questions if you want. Just put in the chat, and we'll put in a brief question about, what the heck is, a lookup table or whatever. And then probably head off into more general questions at the end of the seminar, and those will be off the recording, so you can just ask anything you want. And I will ask the stupid questions to start off with. Okay, let's get going. Hey, Alex.
All right. Thanks, Bob. And I really appreciate the opportunity. I know both Elena and I appreciate the opportunity to come and talk for this Ames research or science research seminar. I know there's a lot of familiarity with doing DOAS and max DOAS within this group here, but hopefully today we'll provide some more background into what did Pandora specifically do during this tracer AQ campaign that I know some of you have heard about already, and maybe give some meteorological background that can explain some of the variability in what we saw in Houston during September of 2021. So as you can see from the title of the talk, we'll be looking at diurnal variability of various Pandora measurements and look at the meteorological variability during the campaign, and hopefully give some insights into future measurement strategies Elena will be able to provide some insight in what you can do with max DOAS as far as pointing and various retrievals of different trace gases. So hopefully this will be kind of open, free-flowing environment with this talk, and excited to see what questions and discussions come out of this. So I won't be providing a huge in-depth overview of Tracer AQ itself, as I know you heard from Laura Judd and John Sullivan a few weeks ago. But it was based in Houston in September of 2021. It was the first time that a large effort had gone back to Houston since Discover AQ in 2013. And actually, for Tracer AQ, we had a similar measurement design, except the aircraft that was flying was not doing in situ sampling of trace gases and spirals, but we did have an aircraft, the G5, that I'll mention a little bit more later. For Pandora itself specifically, our goal was to provide high time resolution column measurements to compare with GCAS, and then, of course, Tropomi and OMI. Of course, this will be the first time that at Discovery Q, we did not have Tropomi up yet. So having all these measurements in one place will allow for validation of Tropomi as well. Some secondary, more long-term goals as far as our thinking for this deployment was to establish a lot of these sites as PGN sites. For those not familiar with PGN, that's the Pandonia Global Network. It's a NASA-ESA really collaborative effort to have a global network of instruments that are similarly calibrated, similarly processed, and are available publicly. So that was one of the secondary goals, as well as establishing a measurement schedule that could allow for future ozone profile retrievals. That's a project that's in the works, and I'll mention a little bit more later. So we had, for our various sites that we had across Houston, one of our main strategies was we had NASA instruments, and then we had also had some of Elena's instruments, and that allowed us to do different things with different instruments, look at different things, do different profiles, stuff like that. So one of the instruments was concentrated in a high temporal resolution sampling, doing mostly direct sun. So you have a lot of direct sun data points, a lot of NO2 formaldehyde ozone data points every hour. The other instrument at the site would be concentrated in doing max DOAS, so doing profiling, using some of the concurrent retrieval techniques, but also gathering data for future development of ozone profile retrievals. So here's a map showing the site distribution across Houston. So the sites that had Pandora were Liberty, which is on the northeast of Houston. You can see on the right-hand side. That was also co-located with an MPL, a micropulse LiDAR. We had the Aldine site, which was a site that had two instruments, one NASA instrument, one of Elena's instruments. We had the University of Houston site, which had multiple Pandoras. We had one at a ground site at the launch trailer, and then we had one about 3/4 of a kilometer away on Moody Tower, which is a 70 meter high building that Elena had her instrument on. So we had this nice perspective of, we could actually compare the columns between these two in proximity sites to see how much of the column actually were missing between 0 and 70 meters. Did that swap displays?
Mm-hmm.
Yeah, it did.
Okay, is that better?
Yes.
Okay. So we had the University of Houston site, which had multiple Pandoras. We also had a ozone LiDAR. John Sullivan, the Langley ozone LiDAR was located at University of Houston. And then we also had the LaPorte site, which also would have had John Sullivan's his tollnet system. And we had two Pandoras deployed at that site as well. So we had a nice distribution of instruments, and we had two other mobile systems, one on this mobile lab here, where Elena had one of her instruments. And then we also had on a pontoon boat a instrument as well. So we had a nice distribution of land sites, but would also a more significant mobile deployment than we've had previously. So using all these measurements together alongside the aircraft and the other ancillary measurements, we can start to look at Houston with different eyes and see what's changed between 2021 and 2013. Here's just a picture of the various sites where they were deployed. I think the Moody Tower site which is on top of that building, as I mentioned, really provides a nice perspective on where it is with respect to downtown Houston. Those who have been to Houston know how many freeways there are in Houston, and of course, there's the Houston Ship Channel, which which is a large VOC and NOx source as well. So it's a very interesting place to measure. But I think we were really happy with where we deployed these instruments and the unique platforms that we measured on. So overall, during the month of September, we had very good data coverage. And when I say data coverage, so we had the sites that are colored, the days that are colored green are days where we had an L0 file for that particular instrument. And you can see, especially during the first half of the campaign, we had very good data coverage throughout. The Laporte site, we had some instrument turnover, so you will see some gaps. But overall, we were able to capture most of the month with a variety of different instruments, and we had good data coverage on days where the NASA G5 flew with GCAS, and that was important for us to be properly measuring on the days where the aircraft was flying, really getting the most bang for our buck. Hurricane Nicholas hit during the middle of the month, and really with lots of cloudy days, a lot of precipitation. There were power outages, so you'll notice those first few days after Nicholas moved out, 19th, 20th, and 22nd. Laporte specifically did not have power, and some of the other sites didn't. So we had some complications to work through during the campaign, but I think we came out with a large amount of data to chew on and lots of different directions to go. So this is a time series of the daily mean total column NO2 from all of the Pandora sites across Houston. You'll see across the top bar of each time series, there's a colored looking bar that's ozone. And that's just kind of approximate ozone. That's just showing and highlighting the time periods where we had what I'll call ozone events, where we had ozone exceedances. And these particular time periods are going to be time periods that I'll pull out later in this presentation to do some comparing and contrasting of some of the measurements. But you can see we had two main ozone events during the campaign. And if you just kind of look with your eye what happened with NO2 in the column during those two periods, we see overall all the sites are higher during these particular ozone events, and as we would expect. So we'll dig into some more of this later, but we saw a lot of variability in between the sites when we had different meteorological conditions, of course, but also when we had different chemical conditions present as well. So I'll hit you first with some obligatory Pandora Trobomi comparisons from the campaign. If I don't show it here, but if you compare the cloud cover that we experienced during the month of Tracer AQ and compare it to Discover AQ 2013, we were slightly more cloud-free, believe it or not, during September 2021 than we were in 2013. If those may remember that during Discover AQ, there was really only one highlight day of the campaign where we had really bad pollution. It was September 25th, 2013. Fortunately, we had less clouds during this month, so we were able to get some good comparisons with Trobomi. The first plot on the left-hand side shows both Pandoras on the University of Houston campus, and then there are values in the lower right. Overall, very good agreement between the two. I was actually very surprised to see this because obviously, as some may or may not know, there's the issue with Trobomi actually, of course, still underdoing it in urban areas. But the latest Trobomi data, we see that we have very good agreement when comparing to Pandora. The Laporte site, we still see some moderately good agreement with some outliers on particular days. And then the Aldine site, we didn't have as good agreement. It looks like we have Pandora is more consistently higher than Trobomi. This will require some more investigation. So Aldine is on the north side of Houston, and this might be something that would be worth looking into with some of the wind analysis to kind of improve what we're looking at. But overall, we saw pretty good agreement with Trobomi overall, and some of these results can be kind of further stratified into where these exceedance days, where the winds out of the south, things like that. So if we start to look into the site-by-site variability in the diurnal column for NO2, for each of our sites. We can start to notice some differences, of course, chemically between these environments. Basically, the data was binned into the morning, which is what the morning is considered any time before 11 a.m. local. The middle part of the day is 11 a.m. to about 1 p.m. local, and then the p.m. time is 1 p.m. and after, to try to capture these different photochemical environments and what's happening with the column measurements themselves. So the sites that are located near major highways, which would be Aldine and either of the Houston, Texas sites, they showed morning and afternoon increases in NO2, potentially indicative of rush hour. I would that's especially the case for Aldine, which it's a little bit more displaced from the Houston Ship Channel and just surrounded by multiple major freeways. So that was very indicative at Aldine. The Liberty, Texas site is a bit of an outlier here. While it is a clean site overall, and we didn't see much variability, some of that was due to a filter wheel issue where we did not have data during the middle of the day due to the instrument saturating, just as I mentioned, due to a filter wheel issue. But the data we did have was kind of reflective of what I maybe thought it was going to look like out there, where you really don't have anything far northeast of Houston. It is considered our background site. And then LaPorte, Texas, which is, I think, one of the more unique sites compared to the rest. It's located near the Houston Ship Channel and near where some of the oil and gas activities are. Between the multiple instruments we had there during the month, we routinely observed high concentrations of NO2 really at any time during the day. No clear diurnal pattern. You would get plumes of things come through, and you would just see a lot of NO2. If we look at the same thing, but just looking at formaldehyde, total column formaldehyde, we see a similar trend actually between a lot of the different sites. We see a general increase in the formaldehyde columns throughout the day. The Houston, Texas site was consistently higher. The University of Houston sites were consistently higher than a lot of the other sites throughout the month. And the Clear Lake Shores, which is technically our pontoon boat data, was more limited in the amount of data it actually collected, but it observed a lot of variability. And when I say a lot of variability, the data that was flagged as good was extremely variable on days where you had pretty clear weather. So there's a lot to jump on here, but we're seeing some interesting things in the data. And I'll mention that the formaldehyde retrieval technically is not operational yet, so the data is technically preliminary or in development. But we're seeing some really promising things out of the data that we are producing. So the next part of this talk will be highlighting two different ozone events and try to kind of stratify the results between these two events, both chemically and meteorologically. So we had the first ozone event that spanned from September 6th to the 11th. It featured multiple C and Bay Breeze days. And we had the highest surface ozone of the campaign during this stretch during this first ozone event. We had the second ozone event, which was number 2, which was the last part of the campaign, spanned the 23rd to the 26th. There were some sea breeze boundaries, but not many that really made it far inland. So that effect was a bit muted if we wanted to try really looking at sea breeze days versus bay breeze days, because their strength were more limited in the second ozone event. And we had multiple ozone exceeding days, not as strong as the first, but we had multiple days between 70 and 80 ppb for the 8-hour average. So I will start to stratify the different sites and their diurnal variability by these ozone events. So if we start to look more detailed at basically each hour of every day for these various days, and look at the diurnal variability, we can start to pick out some interesting things. We can also look at the meteorology and the wind that were occurring at these various sites throughout the campaign. So in the upper left here is basically the hourly NO2 columns for Aldine, spread into the various days by their colors. The time is in UTC. And then below that is a wind rose for the whole month of September for the Aldine site, specifically using actual observations. And you can see that really the northeast and east winds dominated during the month, but we do see periods when the winds are out of the northwest. And this will be a point of comparison with the first ozone event specifically. So this middle column is basically picking out just the diurnal variability for the days where we had that first ozone event number 1, where we had some of the highest ozone. And then below that is specifically the wind rows, only using the wind observations from the days of the ozone exceeded, that first ozone exceedance event. And you can see we have some interesting variability, but at Aldine it kind of remains almost flat during this first ozone exceedance event. We see that winds are predominantly out of the northeast and the east during this first ozone event. We can contrast that for the second ozone event, number 2, where we see much more variability in the column NO2 throughout the day at Aldine. And we also see the winds are drastically different. So, of course, this is going to play a role on what sources are we sampling, what's leading to the increases or decreases in the column. But we see in that the second ozone exceedance event, we have more variability in the column, and we have more winds out of the north and northwest during this period. We can look at the same thing, but for the diurnal formaldehyde columns. The wind rows is the exact same as I showed on the previous slide, but we have the diurnal variability in the formaldehyde column. If we look at the ozone event number 1, we see a lot of variability in especially the morning total column formaldehyde. So we see a lot of variability in this first event. The second event is really a contrast to ozone event number 1. We see lower and generally more stable formaldehyde throughout the day. And once again, a lot of this comes back to where the wind is coming from. You'll notice in the first event, it's out of the east and northeast. To the east of Aldine is where a lot of the ship channel activities are, even though it's a little bit more displaced from that area. We're going to look at the same thing, but for 2 more sites, the Houston site and the LaPorte site. You can see at the Houston, Texas site, so overall, if you look at throughout the month, you see a lot of NO2 overall, and you see a lot of variability, especially in the morning hours. And if you look at the wind rows, you can see a similar thing. A lot of variability throughout the month. Remember, we're a little bit closer to the coast, so we will maybe get some of those sea breeze influences affecting our wind direction throughout the day. So for ozone event number 1, we see a lot of variability in the column in the morning for NO2. Similar to Aldine, we see more winds out of the northeast during this first ozone event, potentially leading to some of the elevated NO2 that we were observing. A lot of variability in the morning, as I mentioned. In ozone event number 2, we see higher amount of NO2 overall during this second ozone event, even though we saw a relatively lower ozone in the second ozone event compared to the first. We see winds are more out of the northwest. And one reason, and that could be leading to some of the higher NO2 columns that we're observing during the second ozone event, mainly because to the northwest of Houston is downtown Houston. You have multiple major freeways. So I would suspect, if I did a further investigation into this, I would suspect that a lot of the NO2 we're seeing is mostly mobile emissions from cars, from the numerous freeways that are spread across Houston. But we do see differences when we start to break this down by these ozone events. So the same thing, but for formaldehyde. If we look at the first ozone event, we're between about 1.5 and 3 molecules per centimeter squared. It's pretty flat. We actually don't see a lot of variability during this first one. If we look at the second, we actually see we're still within that range, but we see a trend of increasing formaldehyde throughout the day, especially on a couple of those days during the second event. And once again, we're more northwesterly in the second event than the first. So that impacts, what sources we're going to be sampling and what chemistry is ultimately happening. So finally, I'll end this part of the presentation with the LaPorte, Texas data. So this is the same thing, but for total column NO2. When the winds were out of the northeast and a little bit of the northwest, we saw more variability in the column for NO2, partly because I would suspect this because we are just south of the ship channel, and where of course you have a lot of sources, so we're seeing more variability in the column overall. However, the second ozone event, winds were out of the northwest, not any immediate sources, large sources nearby that would lead to really high column amounts, and that's kind of reflected in the diurnal profile that we see. Formaldehyde, I thought was going to be interesting as well, and it was because we're located near where a lot of the VOC emissions take place in Houston, at least the anthropogenic ones. So the first ozone event, we The windrow is, of course, the same, but we see a lot of variability from day to day in the actual column amounts at the port. And you can contrast that with the second OSE event, which also we see lower formaldehyde and lower NO2 during the second ozone event, and a lot of that can be explained by basically the meteorological differences between the two events. Really, it can almost skew the way you look at the event, but it's important to stratify these observations by the meteorological variability between these ozone events. Now, I'll tease you a little bit with some of the profiles that we collected during the campaign. And once again, these are just a few days from both of those ozone events. And this is from the currently operational PGN NO2 profile retrieval. We have in the first column the Houston, Texas site. We have the LaPorte site in the middle and the Aldine on the right. And this is for the first few days of that first ozone event. And what's really the main takeaway when I was just plotting these up for the first time was that we are really capturing the variability, especially, and we're seeing that profile mix out throughout the day. Of course, we have photolysis as well, but we're seeing actual changes in this profile, and it's cool to see it in real time. And these data points are colored by time of day in UTC, so you can see as the colors become more red, basically towards the afternoon, the profile is becoming more uniform and more straight up and down, which is what we'd expect. And the same thing can be said of the second ozone event. We see some similar things. We actually see some interesting little features in the profile, little bumps maybe towards the top of the boundary layer where we can sometimes see things collect up there because that's right near the boundary layer cap itself. So yeah, we see a lot of interesting variability when we start to look at these profiles, and Elena can speak more to this, especially in the Q&A. Some things that I've been playing around with, and I will preface that I'm a meteorologist first and a chemist second, but this is more to speak to some of the games you can start to play with the data, the column NO2 and column formaldehyde data that we're collecting. We can start to look at the photochemical environments and looking at what regimes are NOx limited, radical limited, or are we in a transitional zone where we're kind of in the middle?
Okay, so, I'm sorry, I'm going to interrupt here.
Yep, go ahead.
Just like this obviously is very important work to look at these ratios, but I want to emphasize that NO2 and formaldehyde have drastically different profiles. NO2 tends to be very focused closer to the surface, while formaldehyde gets to distribute, especially later in the day, through most of the mixing layer height. So while this is very important to understand how columns behave, I think we should be very careful about what it actually means.
Yep, thank you for that, Elena. Yeah, and that is a great point, and that's why really what we need to do is we can calculate these ratios, but to your point, Elena, it is important that now that we have these other available products, such as the tropospheric columns, yes, the profile is still different. I think ultimately that's why max DOAS comes in, and we can start to do these ratios more properly. Some studies have tried to use satellite data, as we know. Brian Duncan, and people have tried to use satellites, but it is important to note that their profiles are different. And the power of Pandora going forward, I think, is if we're able to get these reliable profiles, we can continue some of this work at looking at the photochemical environments, where we have a lot of interesting things going on. This is an example from Pandora 25, the Houston, Texas site. This is just showing, once again, some of the profile data for NO2 on the left and formaldehyde on the right. And I think there's a lot of opportunity to continue to advance these and find ways to collaborate on some of this work. So I'm getting to near the end of the presentation, and I'm just going to highlight some of the pontoon boat measurements that were made with Pandora 24, and how we can use that alongside space-based remote sensing to look at really interesting things. So this was the amount of data that we were able to get during the month from the pontoon. We had some temperature and humidity issues with that particular instruments, but we were able to make some interesting measurements. You can see there's this period in particular that we are interested in for a variety of reasons. Of course, we see a lot of NO2, but this was also in the direct aftermath of Hurricane Nicholas, where there were power outages and issues across Houston, potentially leading to some different emissions across Houston, as well as the meteorology was kind of in a unique spot during that particular time period. So this is a zoomed in time series from the 17th through the 19th of September. The pontoon was stationary in some spots, but also moving a little bit on the west side of the bay during this time period. And if we look at these time periods compared to Tropomi, so we don't have data at every Tropomi overpass on these 3 days, but below is the Tropomi data from the 17th, 18th, and 19th. And you'll notice something very interesting is this on the 17th, we see some elevated NO2, particularly over the bay. There were clouds everywhere else on these days, but we were able to still capture elevated NO2 on these days, and Pandora is able to capture it in some of these instances where it was able to get data. And some of this was partially due to the fact that we had winds, weak winds out of the north and northwest on each 3 of these days. And we also had cloud-free conditions mostly only over the Galveston Bay, which was very unique and something that we don't often see in Houston, where you have persistent northwest winds and just cloud-free skies over the bay. Of course, a big topic over the last, I would say, 10 years has been looking at these land to water gradients in pollution and chemistry. And this was one really neat example of being able to still get interesting measurements between the clouds, but also capturing this over water. So this was a very neat application of the pontoon measurements, the mobile measurements that we were able to get on the boat. So overall lessons learned and considerations for future measurements. Boat Pandora measurements are fickle, but they can provide high value. And I think this can be said of any mobile measurements with Pandora that have kind of been evolving over the years. Moisture can lead to significant condensation on spectrometers, especially in Houston, where you can get tropical air masses. This has spurred the development of a spectrometer box dryer that we will be deploying on the pontoon boat again this summer to test, to see if we can get more life out of the instrument in such a harsh environment. Part of this measurement schedule deployed in Houston was based around the co-location with the TollNet LiDARs. At the point of the campaign, the NO2 profile retrieval had just become operational, and we were at least producing formaldehyde profile data. There was also a secondary motivation to do, and is in development, this ozone profile retrieval from Pandora that is in the works. It's a funded effort by BIRA to they're funding Luftblick, who does all of the back-end work on the processing and retrieval work for the PGN. They're hopeful, but some of the measurements we made in Houston can be helpful in the testing and development of that. And having the TollNet LiDARs there as a source of intercomparison will be crucial. And hopefully future co-location with TollNet LiDARs will be, as I mentioned, crucial for doing this validation. So I'll kind of wrap up here. So as I mentioned, this was the first major deployment of Pandora since Discovery Q Houston. Overall, we had good data coverage and were able to manage around some instrument issues. We had very good agreement with Tropomi overall. We were able to find distinct differences in the NO2 and formaldehyde columns between the sites and between ozone events. Not every ozone event is created equal, as we can see just purely looking at the wind rows, but also the diurnal NO2 and formaldehyde was different between the 2 ozone events. These column ratios can provide insight, but there are limitations, and that's why we need these tropospheric columns and these profiles to really effectively quantify these things. And that's I think that's one of the big takeaways from this tracer AQ work is, and what we've seen is some of the initial profiles, and just thinking about the power they have to potentially really give us more insight. And for us to get these profiles on a more consistent basis can provide really unique insights into the chemistry and hopefully help us untangle the chemical questions, and not just Houston but other cities too. Additionally, overwater Pandora measurements can provide a unique perspective and can test limits of these Tropomi NO2 retrievals. I know there's been other campaigns that have put Pandoras on boats, such as the Scope campaign that was associated with BOEM. I know they will be putting a Pandora out on a boat next summer as well in the Gulf to further do this validation and try to understand how well Tropomi does over water as well. So with that, I will wrap up kind of this overview part, and I'm happy to take any questions. I know Elena, I'm sure, has been fielding questions as well. So I'll leave with that and happy to answer any questions anyone might have.